Hey, so welcome back, and this is another daily LeetCode problem. So today it was called clone graph, and it's yet again another graph algorithm. And so in this case, what you're given is a connected undirected graph, and you want to deep clone this graph. And so a deep clone is when you are not just kind of cloning the reference to another object, but you're actually like creating a identical version of that particular object, but stored at a different memory location. And so what you do is typically you just kind of create another object, and then you just instantiate it with all the same attributes and values as that other node. It's just a new object. Okay, and so this is kind of a deep clone of it. And so what we're going to do is we're going to perform a depth first search on this graph, and we're just going to visit every node and clone it. And so initially we're just going to clone the value, and we're going to create a clone of each node with the same value. And then in our second iteration, we're going to go through every node and just update its neighbors with a reference to our new nodes. Okay, and so that might not make much sense right now. I think looking at the code makes a bit more sense, but as you're iterating through this array, we're going to be creating something called like this is just the name of the variable, but I call it like a new to old, or no, old to new, and this will actually be a hash map, like a dictionary here. And so we're going to map like the old node, so this would be like old node, to a reference to the new node. And so the first iteration, as we iterate through every single node in this graph, we're going to map the old node to this new node. And then after we have that mapping, when we're iterating through this list the second time, since we have like these new node references, then we can kind of propagate and set its neighbors. And we just iterate through all the neighbors of the old node and reference the ones in our new node with that kind of relationship, that one-to-one mapping that we made. Okay, so the first step is we're going to make that mapping, and then the second step is we're going to assign the neighbors. And it's just very simple this way. And so the first thing is let's define our old to new hash map. And so that looks like this. Actually, we don't need a default dictionary. We can just use a regular hash map. And then the second thing is at the end of this, we're going to want to return the new node that references this current one here. So we say old to new, we pass in this node. And that's because, well, when you call for the node that was passed to us, kind of the head, so to say, of this first node here, when we call this, it's just going to return the duplicated or deep clone version of that node. And so once again, this is just a mapping of this old node to the new node. Okay, so first let's perform DFS to clone old nodes. But this iteration, we're only going to be giving it a value. We're not going to assign the neighbors, so values only. So to do that, we can do it both depth first, or both recursively and iteratively. I find doing it iteratively is cleaner, and you don't have to worry about. Often people say it's a better solution. So let's go ahead and do that. So let's create our stack, and we want to say, okay, while we have something on our stack. And so to do that, initially we want to add a node here. And this is the one that's first given to us. So this is the starting point. But we want to handle a case of, okay, what if this is empty? And so at the very beginning of this, let's just handle this edge case of, okay, if there's not a node here, let's just return none. And so that handles kind of so that we don't get any exceptions. So from here, let's get our current node by popping it off of our stack. And so then we can say, okay, now what we want to do is we want to make a clone of it. So make a clone. And so then we want to take our lookup table here, and we want to at the reference to this kind of old node. This is like, once again, this is the old node that we're popping off from here, is let's make a reference to a new node. And so we do that by then just calling the constructor of our node class, and it's defined up here. And so we're not going to define the neighbors just yet. It's initially just going to be none, which then just sets to an empty array here. Because if it's none, then it just gets set to an empty array. And so we're just going to let this stay as none, but we're going to override this parameter so that we actually give it the same value as this current node. And so we do that by just saying, okay, current.value. And so this makes a new node that we reference with the current node. Great. And so from here, what we're going to want to do is we're going to want to do this for every single one of its neighbors. So let's just iterate through its neighbors. So for every neighbor in current.neighbors, we're going to want to do the exact same thing. And so let's then just add to our stack that neighbor. And so then it just kind of recursively, or I guess in this case iteratively, since we're explicitly defining the stack, it will just keep iterating over this and just clone all of its neighbors. But the one thing we need to check for is, since this is an undirected graph, we may deal with cases where we will deal with cases where we're infinitely looping if we don't mark which nodes we've already visited. And so we do that just by saying, okay, since we already visited this node, or to check if we already visited this particular neighbor, we can say, okay, if this neighbor is not in our lookup table, then we know it hasn't been cloned yet. Great, so we only want to add to our stack that neighbor if we haven't already cloned it. Great, and so for part 2, then we want to update the clone's neighbor references. And so to do that, what we're going to do is we want to just iterate through every key in our lookup table, or really through all the old nodes. And so let's do that by, okay, so for every old node in our old to new lookup table, we want to look at that particular key, and we want to say, okay, and I'm just going to, so that this isn't at the bottom, let's just zoom in a bit, just so it's easier for you all to read. So for every old and old to new, let's iterate, and we want to say, okay, let's update its neighbor references to point to these new clones that we made in this previous step. And so we say, okay, at this old node, let's index into our class here, and we want to get our current node that we're looking at. And so what we're going to do is we want to iterate through all of its neighbors. So for every neighbor in, I think once again, our neighbors. Is it neighbor or neighbors? I think it's neighbors. Yeah. Great. And so then we can say, okay, then at this reference to this neighbor, or wait, no. At this reference to this old node, we're going to want to append all of the neighboring nodes. So I think once again we do want to do that. So let's iterate through all the neighbors, and we say, okay, let's assign at this old node. Yeah, so this is getting back our like clone of our new node that we made, because when we reference this old one, we're getting back the new clone. And so then let's just say, okay, we want to update its neighbor, so we get its neighbors through here. And so once again, this will be an array. And so now we want to add to this array the new reference to this neighbor, because we know we have the new version of this neighbor in our lookup table as well. So we just put in here in this array that new node, but we want to grab its new reference. Great, and so we just iterate through every node in our lookup table, all the old ones. And so then we want to say, okay, in our old node's neighbors, let's iterate through them. And we want to set at the new reference to our kind of cloned version of this old node that we're looking at. Let's add to its neighbors. Here we index into that attribute for our neighbors, and we want to keep adding the clone of our neighbor. So let's try running that. Oh, local variable reference for assignment. Instead of if, so for every neighbor. Great. And that runs. So yeah, sorry about the little mishap there. It was hard to explain that part, but yeah, I found splitting into two parts is what made it make sense. The first catch is, okay, it's easy if you have a lookup table to translate the old to new. And by splitting into two steps, we first do a depth first search so that we can clone all the nodes, just their values. And so we just update them, and then we want to iteratively look at all of its neighbors, and we just want to avoid doing repeated work or really get an infinite loop by just checking, okay, have we already processed this old node? And then once we have that, we just iterate through all the old nodes. Then we say, okay, for each old node, for every neighbor, we want to add to the new reference of that deep clone that we just made. And let's just add the reference of the deep clone of that neighbor. We just add all the neighbors and we go to the next node. And then finally, they just want you to return the new reference of the deep clone of the first node that they gave you. So yeah, I hope that helped. That was today's daily problem, and good luck with the rest of your algorithms. Thanks for watching.